The final thing we'll look at today is on page 577, example 3, which looks at how do we multiply two binomials. There are a couple different methods for this, and we're just going to have a quick introduction to multiplying binomials. You'll spend more time in Algebra 1 on this, but I wanted to give you this introduction so we've seen this before. When we multiply binomials, the first method we're going to use is drawing a picture. In other words, using algebra tiles. And like we tried last time, you could actually get your algebra tiles out. I have some here for us that we could use. You could also just plan to draw this, although know that they might not be perfect squares, rectangles, etc. when you draw it by hand. I'm going to try drawing this first one, and then we'll see if we can fit our algebra tiles to our drawing and see if that helps us piece this together. Our first example is 2x plus 1 times 3x plus 2. So the idea is that I would have a rectangle when I'm using area to help me solve this. And the dimensions of the rectangle would be 2x plus 1 is the length, and 3x plus 2 is the width. Now, as I draw, I'm going to try and draw so that the first one has 2 x's. Remember, those are about an inch, plus 1, which is about a quarter of an inch. That might be a little bit big. And then the other side, the width is 3x, 1, 2, 3, plus 2 units, 2 singles, which are, again, about a quarter of an inch. And then that's the length and the width, and we extend that to make our rectangle. And we know each of these pieces. So I know this is all the way across 1x, 1x, and 1. So x plus 1 is 2x plus 1. And again, the width is x plus x plus x plus 2. 1 and 1. And now we can look at each of these, and this is where algebra tiles come into play. Each of these represents some algebra tile. These largest boxes are x squareds. X by x is x squared. The long skinny rectangles come from our x wide and 1 tall, which is x. X times 1 is x. That's true here for the vertical pieces as well. They are x tall and 1 wide. So each of these is also x. And then these small boxes represent this 1 by 1, 1 wide and 1 tall. And so each of those represents an area of 1. And so when I simplify this, when I add this all up, I have 1, 2, 3, 4, 5, 6 x squareds. I have 1, 2, 3, 4, 5, 6, 7 x's. And I have 1, 2 constants or single units. Now, that was using the area formula, so actually drawing this out. But what if I had a really long or cumbersome problem? 15x plus 24 and 60x plus 30. Okay, I may not want to draw all of these boxes and add them up. There are other ways to do this, one of which is distribution. You actually distribute twice. And another one is FOIL. Most of this, I would encourage you to keep using this area formula. This can be our go-to for now. But I do want to show you there is another way to do this, and we sometimes call it the FOIL method. Times 3x plus 2. When I use FOIL, FOIL stands for, I'm going to leave that box up there, firsts, outsides, insides, lasts. and I'm going to add those 4 things together. So what do I mean by each of those? Well, firsts means the first term in each binomial. We're going to multiply together. 2x and 3x are our firsts. Then outsides. This means the outermost terms of the whole product. 2x is on the outside and 2 is on the outside. So we're going to multiply together 2x and 2. Then insides. This means the innermost terms. So we go closest to this multiplication. We have 1 and 3x. And so we multiply those together right on the insides. And then last, you may have guessed it, this is the last term in each binomial, 1 and 2. You may already be starting to see we're going to end up getting that same answer. If not, let's keep stepping through it. 2x times 3x, we multiply the coefficients first. 2 times 3 is 6, and x times x is x squared. Plus 2x times 2, again, we multiply this coefficient times the constant. 2 times 2 is 4 times x. 1 times 3x is just itself, 3x. And 1 times 2 is 2. Now we have our 6x squared looks the same as up here. And 2, our constant, looks the same, but the middle doesn't look the same. That 7x we don't see down here. Well, we're not done simplifying yet. 4x and 3x are like terms. They have the same variable and the same exponent. Really, that's an exponent of 1, and so they're like terms. So I can add their coefficients. 6x squared stays the same. 4 plus 3 is 7, so that's 7x plus 2. And it checks out. We get our same answer using firsts, outsides, insides, and lasts. I would encourage you to use the area formula and then maybe check it using first, outside, inside, last, or vice versa. This is a good opportunity to try quick checks. It'd be good to try at least A and B, and I'll put your answers here in just a second. Pause and try those. This is quick check 3. Alrighty, our answer for A, quick check 3A, is 2x squared plus 7x plus 6. And for B, 6x squared plus 11x plus 4. I would encourage you, keep using that area formula or your algebra tiles. If you would like to try the FOIL, that is a great method, but you will spend more time on that in Algebra 1, so don't be worried yet. There's lots of different methods to solve these problems. Thanks, guys.